So, when we're talking about hypothesis tests, as I said before, our ultimate decision is always given in terms of the null hypothesis, at least in a sense, that we're always working in terms of either rejecting or failing to reject the null hypothesis. And when we talk about more formally stating a conclusion later, I'll be a bit more specific about the ways that we can change how we phrase that, depending on what sort of assumption, what sort of claim we're working from initially. But everything we do happens in terms of that null, that's our starting point, and then how we phrase, how we set up the test itself runs in terms of our alternative. That's where we get the idea of left and right tails and what our proof, as it were, what our evidence really represents in terms of a distribution and in terms of the sample we drew. But when we're talking about this, well, we're not always getting 100% certain guaranteed results, so there's always room for an amount of error. There's always a chance that the sample we draw isn't as good as we think it is, and that's where we get these two things called our type 1 and type 2 error. Because fundamentally, as I said, two things can happen. Either we reject or we fail to reject. And on some occasions, we will fail to reject something that is false, and we can also reject something that is true. Again, be careful with that language. Fail to reject, it's kind of a weird double negative, but that's how we phrase these things. Anyway, when we reject a true null hypothesis, we are committing what is called a type 1 error. And the probability associated to this kind of decision is given a value alpha, which is something that we'll see later in the context of a level of significance. But for now, that's just how we'll think of it, is in terms of whether we reject something that is true. On the other hand, we commit what's called a type 2 error if we fail to reject a false null hypothesis. That is to say, we don't find enough evidence to reject something that we really should reject. Either we just get a bad sample or the sample just doesn't fit. If we fail to reject something that is actually untrue, we are committing a type 2 error, and this has its own associated probability beta, but that probability beta doesn't have quite as clean of a use as alpha does, so we don't see it quite as often. Anyway, whether we want one or the other more depends entirely on the scenario. As we'll see with our next example, what can happen in either case. So for this example, we have that the USDA limit for salmonella contamination for ground beef is 7.5%. A meat inspector reports that the ground beef provided by a company exceeds that limit. You perform a hypothesis test to determine whether the meat inspector's claim, that is, the claim that it is above the limit, is true. When will a type 1 error occur and when will a type 2 error occur? Which is more serious? So we can start here by setting up our notational carefully, that is, setting up what our hypotheses and our claim are, like we did in that last example. And for that, I'll start with what's given by the statement, what's given by the inspector in this case, the claim that the proportion we're working from is bigger than 7.5%, so P is bigger than 0.075 is our claim. And remember, when we're talking about these hypothesis tests, we always have one thing or the other. Here's our one thing, so the other is its opposite, but the proportion is at most whoa, what happened there? That's too many fives. 0.075, where because that has an equality in it, that's our null. So our claim is the alternative that the proportion is bigger than 7.5%, where just for reference, sometimes when we're doing this, we will denote the alternative with an H1. That's what the old book used to do. It's really not that big of a difference. Just know that sometimes if you're looking at other resources, you might see that instead. It means the same thing. Anyway, from here we can talk about what sort of conclusions we may draw and how this would fit into our scheme with these errors. And in this case, let's say that our test reveals that we should reject the null hypothesis. That is, we should reject the idea that the proportion is at most 7.5%. So that means we are in some sense finding evidence for the claim that the proportion is bigger than 7.5%. So if we find evidence supporting that the proportion is too big, that means that, well, too much meat has salmonella, which is really weird to think about, that any having salmonella is acceptable, but, you know, that's how these things have to run.
Take the number of vehicles in the field, A, multiply it by the probable rate of failure, B, then multiply the result by the average out-of-court settlement, C. A times B times C equals X. If X is less than the cost of a recall, we don't do one.
There's an amount of slippage, no matter how bad that might be for you or me, because there's so much in there that some of it just gets missed.
Are there a lot of these kinds of accidents?
You wouldn't believe.
But anyway, in this case, if we find evidence supporting our claim, finding evidence supporting our alternative, that means we're kind of incurring a recall. So if we find evidence supporting the alternative, that is, we find evidence rejecting the null, but we perform what is called a type 1 error, that is to say, we should not have rejected that null hypothesis, well, it's not such a big deal. Just costs the company a little bit of money. Maybe a lot of money, it depends really, but at the end of the day, losing money is what companies do most of the time anyway if you follow their taxes. So it's not the worst thing in the world, although it might put some people out of work. So we would say that type 1 error, pretty callous to say it that way, but compared to what we'll see with the type 2 error, it's not as bad. That would mean, in this case, we probably get a recall of some of that meat that we don't need. Because we are saying that the proportion is too high when, in fact, it's actually within the allowable range. On the other hand, if we're going to perform what is called a type 2 error, that would mean we don't find enough evidence to reject that null hypothesis, which would be we expect the proportion is less than 7.5%, when in fact, that's not true. It's actually much higher. Well, maybe not much higher, but it is higher than we want. So a type 2 error would be a case in which we fail to reject that null, we fail to reject that supposition, in this case, that the proportion is within the allowable range, and we end up sending out meat that will get more people sick than we should be willing to accept.
On a long enough timeline, the survival rate for everyone drops to 0.
So, type 2 error, in this case, again, means failing to reject a false null hypothesis, in this case, that the proportion is within the allowable range. So, in that case, people get sick or die. I don't know how common it is to die of salmonella anymore, but it's not a pleasant situation to be in, even if you do come out of it pretty well. But in this case, I guess it would depend on your position, whether you think the type 1 or type 2 error is more serious. Me personally, I think that people getting sick is a bigger concern than the meatpacking industry losing money, but you may have a different opinion. In any case, these are the two things we can look at with these types of errors. Next, we're going to talk a little bit more about what that alpha value actually means, how it can actually be used more reasonably in a hypothesis test through a thing that I mentioned before called the level of significance. We'll see that next.